Greetings and welcome to another installment of Easy SPSS. I'm Dr. Gross and welcome back. In our previous video, we did a KW test, which shows significant differences in height and weight across three groups of a independent variable exercise levels: low, medium, and high. However, the Kruskal-Wallis does not specify which groups differ. So in this tutorial, we'll use the Mann-Whitney U-tests to conduct pairwise comparisons and identify which exercise levels are there significant differences between exactly. And you might ask, as I asked, why don't we just skip the KW and go straight for the Mann-Whitney? Well, before running a Mann-Whitney, you would usually perform first a Kruskal-Wallis test because at first it compares three or more groups simultaneously, which we have, and it determines if there is a significant difference somewhere within those groups or among them. So, for example, if the KW wasn't significant, then we can just stop there because there's no evidence of any meaningful difference between any of the groups. But if the KW is significant, it tells us, it doesn't tell us which groups differ, but it tells us a difference does exist and it is worth and warrants further investigation. So let's go ahead and get set up for the Mann-Whitney U. We have our SPSS open, and this is data view where each column represents a variable, row represents a case or a participant. And let's go down. There it is. In variable view, now the rows represent the variables and the columns represent characteristics of those variables. And I would go to open file, and wherever you saved that data set, you would retrieve it there. I already have mine open. And so here we are in data view. I can see all of my data. Value labels. Easy switch between codes and descriptions. And you can see my participants, my variables. Not too long ago, we added our missing values. And if I switch to variable view, I can now see all of my variables and then all of the characteristics of those variables, including the missing values that we added for height and weight. There were 4 cells that we filled in, or two participants, 2 cases had missing values. All right. So first, I'm just going to run through the Kruskal-Wallis to connect these 2 videos in series. So for that, we went analyze non-parametric legacy dialogues, k-independent samples. And we had height and weight, and we had our grouping variable as exercise level. We defined the range as 1 for low and 3 for high. And then we clicked Kruskal-Wallis, and I recommended the descriptives. Okay, and we'll run that data. And in the end, we said, okay, down here, there is a significant difference for weight and height, but we don't know where, right? Among which groups, we don't know. Right? But we do know that there's a significant difference somewhere. So this was the reason that we furthered the analysis by running the Mann-Whitney, which kind of serves as a post hoc test for us. So again, we can do this straight from the output dialog or output window. We could do it here, or we just want to show you the different options that you have. So Now for the Mann-Whitney, we'll go to analyze, non-parametric, legacy dialogues, and now two independent samples. As the Mann-Whitney will compare two at a time, as the Kruskal-Wallis was able to handle three or more. So we'll go to analyze, non-parametric, legacy dialogues, and two independent samples. So from here, we're going to move height and weight into the test variable box. I'm going to right click, display variable names. It helps me visualize it easier. And so I'm going to move height. I'm going to hold control, release it, selects both of them. I'm going to move height and weight to the test variable box. And for the grouping variable, we'll move over. So you just click and click again, a different method of getting them over into the boxes. We'll move exercise level into the grouping variable box. But again, we need to define those groups. So we'll click define groups, and group one is 1, and group 2 is 2. And so what we're doing here is we're comparing the low and the moderate groups. And so we're going to have to repeat this. So we'll click OK and make sure that the test type is selected, the Mann-Whitney. And then we're going to click OK to run the test. Now, again, we're going to have to repeat that process for the other two comparisons that we need to make. So we've already done 1 versus 2. Now we need to do 1 versus 3 and then 2 versus 3. So I'm going to do that fairly quickly. Analyze, non-parametric, legacy dialogues, 2 independent samples. I can see what I've already done, 1 versus 2. Now I'm going to compare 1 and 3. Everything is still the same. Okay. And now I'm going to do it one more time. Analyze, non-parametric, legacy dialogue, 2 independent samples. And everything else is still the same. I just want to redefine my groups. And so now I'm going to have the final pairwise comparison, the moderate versus the high group, 2 versus 3. And I'm going to click OK. All right, so if I go over here, this was the KW test that we ran, and it indicated that there was a significant difference. We just didn't know where. And so here are my Mann-Whitney U non-parametric tests, with those 3 pairwise comparisons that we performed: 1 versus 2, 1 versus 3, and then 2 versus 3. So it's 3 pairwise comparisons. So let's start at the beginning, which is the best place to start. So here we are with our first Mann-Whitney U test. So let's interpret this output. The ranks table. This displays the mean rank for each pair. So how you would interpret this is if one group has a significantly higher mean rank, they tend to have higher values for that variable. So comparatively, moderate to low has significantly, we don't know that, but I would consider it a significant difference in the mean rank. So 10 versus 2. So significantly higher mean rank would indicate or might indicate that they have higher values for that variable. The test statistics table is where the Mann-Whitney test statistic and values will be reported. And so if we look at the table, we can see that the Mann-Whitney U for height, and we're looking at the two-tailed significance value. A p-value, excuse me, a significance level p-value equal to 0.011, which is less than 0.05. So a significant difference in height between groups. And then also p-value less than 0.05 at a p equal to 0.008. So also a significant finding. Now, in our interpretation, right, in our example, when comparing low to moderate, when comparing low to moderate, right? This is what we were comparing first. When comparing low to moderate exercise levels, there is a significant difference for height between these low and moderate groups. And there is a significant difference in weight between these low and moderate groups. And so now if we go down and look at our next test, try to highlight all of it. If we look at our next comparison, this is comparing the low versus high groups, right? And I can see again the mean ranks look to be fairly different to me, but we'll have to come down here and look at our test statistics. And so for height and weight, the two-tailed level of significance is less than 0.01 in both cases. And so how you would interpret that is you would say, well, high exercise participants are significantly shorter and perhaps weigh less than low exercise participants. And so again, the mean ranks between high and low groups, there is a significant difference for both height and weight. And the last pairwise comparison that we ran is right here. And not immediately a huge difference in the mean rank. This one perhaps is more than double. So let's look at our test statistic for the Mann-Whitney U. For height in inches, the two-tailed level of significance is above 0.05. So not significant for height, which we could have, and we did assume, or I did assume before I looked at the test statistic. Not a huge difference in the mean ranks, and likewise, not significantly different. Now, if you look at weight, there is a big difference in the mean ranks, and our test, Mann-Whitney test, shows that it is in fact a significant difference at a level less than 0.05. And that is correct. Comparing moderate to high groups, we have no significant difference for moderate and high exercise levels. if I can get it right. There we go. P equals 0.336. So no significant difference between moderate and high groups as far as height ranks are concerned. However, for weight, though, we did have a value of less than 0.05 at P equal to 0.013. And so we could say then that there is a slight significant difference between moderate and high groups when it comes to weight. And so the Kruskal-Wallis identify that there is in fact a difference in these three groups, or among these three groups, which is why we used it in the first place. So it had more than two groups. And then the Mann-Whitney U pinpointed, where those differences were, where those significant differences were, and found that low versus high was the strongest difference, and then moderate versus high showed no significant difference in height, but a slight significant difference in weight. And so, key takeaway here is when should you use this Mann-Whitney U? Well, if you're comparing two independent groups, you could skip straight to a Mann-Whitney U. Or if and definitely if it's not normally distributed, which is why we're using this non-parametric test also in the first place, or I guess that would be second place. First, we did the KW because we had more than two groups. We had three, low, moderate, and high, and we wanted to see if there was a difference anywhere before maybe conducting analyses that were needed. But it did show a difference, and so then we furthered the analysis by conducting three Mann-Whitney U tests to look at those three pairwise comparisons. And this served as our post-hoc test and let us know where exactly those differences were. And so in short, the KW, is there a difference anywhere? Is this worth investigating further? And then the Mann-Whitney is, okay, it was worthy of further investigation. So where exactly is that difference? Or where are those significant differences? And so since ours, KW, was significant, we proceeded with the Mann-Whitney use. This is Dr. Gross signing off. Stay tuned for some more videos as we continue our SPSS tutorials. Thank you again. See you next time.